All right, this is Radical Skills Day. We're just going to take a day, not learn anything really new, just strengthen our skills with simplifying, adding, subtracting, multiplying, dividing when dealing with radicals. Usually square roots, but we'll also have some cube roots, maybe other ones, but a lot of times they're square roots. Now, when we simplify the square root of 45, what you're finding is square roots that go into 45. We've already talked about simple radical form. Just involves finding whatever square roots go in there and taking them out of the square root sign. So our square roots are 1, 4, 9, 16, 25. And you can't go too far before it's impossible to find one that goes into 45, or the biggest one anyway. So our biggest one has to be 9. So 45, 9 times 5. The 9 can come out. Only perfect squares are allowed to come out. We're left with 3 times the square root of 5. All right, nice simple one to start with. Common things will be taking the 9 out and not square rooting it, but just don't overlook that and you should be fine. Okay, a little bit more difficult. This one's got some letters in it, got some variables. You can take out even numbers of variables. So first of all, the 32, 16 times 2. So I'm going to take a 16 out, and it's going to turn into a 4. There's already a 5 there, so the 4 that comes out, the 5 that's already there, give us a negative 20. The 2 is going to stay inside because it doesn't have any perfect squares that go into it. Now, with your letters, with your x to the 5th, you can take out 4 x's, but you can't take out the 5th. So consider x to the 5th to be x to the 4th times x. Now, the 4 x's can come out, and when you take the square root of x to the 4th, you get x squared. The 2 we need to leave, the x we need to leave. So far, everything else has come out front. Y squared, since it's even, make sure you cut it in half. Writing a y squared on the outside would be a common mistake. Z to the 4th, z squared on the outside. The 2 and the x that were not part of perfect squares have to be inside. So here's our simplified version. We don't want stuff under the radical if it can be outside the radical. That's what makes it simplified. All right. So let's talk about combining, adding and subtracting radicals. These add and subtract just like x's and y's, right? You don't combine if they don't match. 3x plus 2x plus 4y is 5x plus 4y. It's not 9xy or anything like that. So we need to simplify these radicals and see which ones match and which ones do not. Now I made these cubes so that we could practice simplifying cube roots instead of square roots every time. So when you simplify a cube root, you have to find perfect cubes that go into that number, not perfect squares. So perfect cubes are 1, which is never going to be one that we factor out. 2 cubed is 8. 3 cubed is 27. 4 cubed is something. 4 cubed is 64. And I think that'll be as many as we can find in this particular problem. So we need to find 1s, 8s, 27s, and 64s that go into these numbers, simplify them, and see what we're left with. Okay, so 40, 8 times 5. The 8's going to come out. It's going to become a 2 because the cube root of 8 is 2. So negative 6 times the cube root of 5. All right, the next one, 64 64 won't go into 108. What goes into 108? 27 goes into 108. It's 27 times 4. So the 27 can come out and become a 3. Again, cube rooting it. So we have a 2 already there. Now it's a 6 because of the 3 that came out. Cube root of 4. A common thing would be to think you can get that 4 out of the cube root because you're so used to simplifying square roots. This is a cube root, 4 will not come out. No perfect cubes will go into 5. No perfect cubes will go into 6. So now if they look alike, as in they have the same root, add them together. We have negative, let's just go in order of what's under. We have 6 times the cube root of 4. We have negative 9 times the cube root of 5, when I put those two together. The cube root does not change. It's just like when we add x's, you know. Negative 6x minus 3x is not negative 9x squared or anything like that. The cube root of 5 stays the same just like an x would. And then the cube root of 6 has nothing to pair up with. So there's adding and subtracting, along with some simplifying of cube roots. Moving on. Multiplying. When you multiply two roots, you multiply the numbers underneath, and then you simplify if you can. All right, so 6 times 15 is 90. All right, multiply the 2 underneath, leave it underneath, and then then simplify what you can. I can see right away that 9 goes into 90. 9 could come out and become a 3. Final answer, 3 square root of 10. I want to make a point on one of these. Let me get my calculator out. That point is we are simplifying. We are not changing anything. So you might not be able to do this on your test, but if you're just checking or doing a homework problem, we did the square root of 6 times the square root of 15, which should be 9.486. If we did our work correctly, then 3 times the square root of 10 is 9.486. So anytime you simplify something, you can check the decimal values, and that might not necessarily tell you how to fix a problem, but it would tell you that you have a problem. So there's multiplying. What about multiplying to like this? All right, we have multiplied polynomials where we distribute FOIL, if you want to call it that. This is just going to have some radicals in it. So I need to do the 1 distributed to both. I need to do the 4 square root of 7 distributed to both, and then simplify. All right, 1 times 3. 1 times 2 square root of 7. 4 square root of 7 times 3. Multiply the 3 and the 4. Leave the square root of 7 alone, just like 4x times 3. And 4 times the square root of 7 times 2 times the square root of 7. Multiply what's outside, multiply what's inside. Outside, 4 times 2 is 8. Inside, square root of 7 times the square root of 7 is 7. You could think of it as the square root of 49 and then square root it, or you could just think of it as those two square roots cancel each other out. Common mistake would be doing 8 times 49 here. All right, those square roots just cancel each other out, while the 4 and the 2 actually multiply together. So, like terms, 57 for these two, 14 times the square root of 7 for these two, and that's it. All right, so we can FOIL with these square roots. You can multiply them pretty much like you would any expression with variables in it. Dividing. Dividing is when it gets a little more tricky. Another word for dividing square roots or radicals is rationalizing. We've covered this a little bit so far. When you rationalize, basically what the term rationalizing means is you cannot have an irrational number on the bottom of a fraction. The square root of 5 is an irrational number. All right, it never repeats, the decimal never ends and never repeats. That's irrational. It cannot be expressed as a ratio or as a fraction. So we need to rationalize because you're not allowed to have those in the denominator. Now, if it's part of a binomial meaning two parts that are added or subtracted, then your rationalization is going to happen by taking the conjugate of the bottom, which is the same thing with a plus instead of a minus, and multiplying the top and the bottom by that exact thing. All right, it has to be the same top and bottom because we don't want to change the value. And when you multiply a fraction by the same thing, you're really just multiplying it by 1. You're just changing the way it looks. The reason we choose the conjugate is because when you FOIL the bottom, the O and the I parts are going to drop out. And those are going to be the only two parts that have radicals in them. So let's do the top first. When we FOIL the top, I get 5 times 2 is 10. I get 5 times the square root, 5 times 5 square root of 5 is 25 square root of 5. Negative square root of 2 times 2, negative 2 square root of 2, minus 5 times the square root of 2. All right, that's square root of 2, 5 square root of 5, 5 square root of 10. On the bottom, 2 times 2 is 4. 2 times 5 square root of 5 is 10 square root of 5. But then right after that, I get negative 5 square root of 5 times 2, which is negative 10 square root of 5. Every time you multiply two conjugates together, the O and the I, you know what I mean by that, right? When we FOIL, the outers and the inners always cancel each other out because they're conjugates. They will always be equal and opposite. And then when you do your L's, I have negative 5 square root of 5 times positive 5 square root of 5. The 5 and the 5 make it 25. The square root of 5 and the square root of 5 make it 5. 25 times 5 is 125. And because those middle two terms canceled out, I have a 129 on the bottom, and I have no square roots anymore. So it doesn't look like anything will simplify on top. And the bottom is now 129. All right, so that's dividing. That's when you divide by a binomial with a radical in it. I'm just noticing, I was checking this over, I made a mistake. Hopefully you saw it. Easy to do when you do a lot of little calculations. This is negative 5 times the square root of 5 times positive 5 times the square root of 5, which makes negative 125, which makes negative 121, right? I think I'm good now. So you can do an over negative 21, you could put a positive 121 on the bottom and change the signs on the top to negative, but one way or the other we need a negative that I had left out. I apologize. All right, moving on. Last one. We talked about this in simple radical form, but I just want to do one more just to make sure. You cannot just go, if I have 2 over the square root of 7, and I want to simplify it. Because it's a square root, I just multiply by the exact same thing, and I get 2 times the square root of 7 over 49. That's only because square roots are what you need to multiply by itself twice. Won't work with other roots. I need to multiply this by the fourth root of something, top and bottom, that will end up with a perfect, giving me a perfect fourth power underneath. Now you can go through all your perfect fourth powers and look for them in that way, or you can think about what you have and what would make it a perfect fourth power. 27 is 3 cubed, agree? If I need to turn 3 cubed into a perfect fourth power, then I just need to multiply it by 3 to the first. All right, so just 3 here and here. Choosing that 3 is the sometimes tricky part, but it's not too bad if you think about it. I basically need to have a multiple of 4 as my exponent of the power. I've already got 3 of the 3's, I just need one more. All right, so the top is the fourth root of 6. The bottom is 5 times the fourth root of 81. And the reason we made that into an 81 is because 81 is a perfect fourth power. While we're talking about it, if you need to do a fourth root, that's the same as a 1/4 power. Make sure you put that 1/4 in parentheses, or else trouble will happen. And there's the 3. The fourth root of 81 is 3, and usually the fastest way, it may be the only way to put that in your calculator, is raise it to the 1/4 power. So we get a 3. So I've got the fourth root of 6 over 3. 3 times 5, I mean. Sorry again. Fourth root of 6 over 15. All right, so there's our skills. Add, subtract, multiply, divide, working with radicals. You don't do a whole lot of these, so that's why I need to practice some. All right, so I hope you've enjoyed the radical skills. It's been wonderful. Young out.